All right, so this is going to be the first video of the Unit 2 packet. So we're going to start on page 2. Okay, so in this video we're going to be going over how to translate a position versus time graph over to a velocity versus time graph. And this can get a little bit confusing, so I'm going to try to be as thorough as I can with this video. So we're going to start off nice and easy. We're going to look at our position versus time graph. So remember, on position versus time graph, slope equals velocity. Okay, so that's something we already have done. Okay, so slope equals your velocity. When we do a velocity versus time graph, now our slope is going to equal acceleration. Because if we're changing our velocity, that means we're accelerating either in the positive or the negative direction. Okay, so if I look at my position versus time graph here, the first one, okay, what I see here is I see a position here. Let's just say this is 5 meters. And it's not moving. Okay, so it just shows that you're just staying in one position at 5 meters. So if I were to ask you to translate that over to a velocity versus time graph, 0 is going to be down here where the x and the y meet. Okay, your x-axis is your time, so nothing new there. And your y-axis is going to be your velocity now. Well, if I'm standing still, I have a velocity of 0 meters per second. So that basically means is my velocity graph is just going to follow that x-axis right there and continue at a 0 meters per second since I'm not moving. Okay, so you got to really make sure you're paying attention to where the y and the x-axis meet, because that's where velocity would be 0. Now if we go down here to the next one, it's pretty much the exact same thing, but now we have a negative 5 meters, and this is just an example, could be any number. But the point is this is 0 right here. And it looks like we're just staying at negative 5 meters. Okay, so we're below that x-axis. And we're not moving, still not moving, so my velocity would still be 0. Okay, so we would just stay right there. Now, some confusion that I've seen is students see that right here, well, this line is above the x-axis, so therefore my line would have to be above the x-axis right here on this next graph. Okay, but the problem with that is if you do that, now all of a sudden you're saying you have, and let's just say you did it at 5, now you're saying you have a velocity of 5 meters per second instead of saying that you were just standing still. Okay, so position cannot really correlate over to here. Okay, so you cannot just take that line and move it over there. Okay, and let me kind of clear that up just to make sure that just doesn't confuse anybody. All right, so moving down to this one. If I look at my slope, okay, I can see that this is a constant positive slope. Okay, it's not changing. If you were to find the point of the slope at this point here, or this point here, or this point here, it would all be the same. Okay, so let's just say for the sake of argument, this would be 5 meters per second. So that means no matter what time it is, it's always going 5 meters per second. So that means I'm actually moving now, so I do have velocity. Okay, so we're going to take that over to my velocity versus time graph. So remember, 0's down here. And so if you did like your 1, 2, 3, 4, and 5, that was basically stating that I'm going to go a constant 5 meters per second. Okay, that just means that's basically like cruise control. You're just staying at 5 meters per second the entire time. So one takeaway from this is you got to be careful which graph you're looking at. Okay, because if you look at this line right here and you think it's a position versus time graph, and then you see a horizontal line, well, now you're assuming the object's not moving at all and there is 0 motion or no velocity. But if this is a velocity versus time graph, now you're just telling me that it is going constantly 5 meters per second. Okay, moving on to the next one. Pretty much the same thing. We're just going the negative direction, so this would just be a constant negative. Okay, and for the sake of argument, we'll do this one as a negative 5 meters per second. Okay, so if you go over to my velocity versus time graph, anything above the x is going to be positive, anything below would be negative, and this x-axis is going to be 0. So we'll just say this is going to be a negative 5 meters per second right here, and we're just going to stay that negative 5 the entire time. Okay, so only difference between the graph we just did and this one is one would be a positive direction, one would be a negative direction. Both are staying at 5 meters per second. Okay. Now we get into the next part of the graph where it gets a little bit more tricky. Is now we actually have acceleration. We're actually speeding up, slowing down. Okay, so what I like to do is I would see one, what type of motion is going on? Is it speeding up? Is it slowing down? Is it going constant velocity? Well, this one, if you look at the slope, okay, your slope gets steeper and steeper as you go. Okay, so if I said velocity, if I actually calculate the velocity like right here, just for the sake of it, I'm going to say that's 1 meters per second. And let's just say that one's going to be 2 meters per second. And then that one's 3 meters per second. Okay, the point is your slope is getting steeper and steeper, so your speed is going up. Okay, and it's going in the positive direction. Okay, we're still going up, so that's going to be a positive direction. So if my speed is going up, that means I'm accelerating. Okay, so now my velocity is changing. So I can't just do a flat line anymore. Okay, because that means velocity is not changing. And I can't go along the 0 line because that means I'm not moving at all. Well, this one I am definitely moving. So if I am increasing velocity, it's going to look like this. Now, for this unit and pretty much for Physics 1, for this physics course, we're not going to worry about, you're not going to see a curved acceleration like that. We're going to assume constant acceleration for now. Okay, so we're not going to get that deep into it. So we're going to assume this is constantly accelerating per unit of time. Okay, so the key thing here is you got to look at where is 0 on this graph. And you got to look at where's your arrow going. Okay, so my arrow's going up, so that means we are going away from 0. And if you are going away from 0, that means you are speeding up. Okay, so it really helps to pay attention to that 0 line and see, are you going towards it? Or are you going away from it? Okay, so my velocity is increasing. So velocity is going up. So therefore, it is accelerating. So we do have a slope now, so now we could find acceleration if we want to. So remember, acceleration equals slope. Now we're going to go to this next one. Is what we're doing is, if you look at my graph, it's actually getting flatter and flatter. Okay, so that means I am slowing down. And you're going down, so you're going to have a negative slope, so that's still going to be in the negative direction. Okay, so slowing down. So for the sake of argument, we'll say the slope here is -8 meters per second. And then right here, it's -6 meters per second. And then it's -4 meters per second. And then -2. Okay, the point is that your velocity is going down towards 0. Okay, so when you come over to this velocity versus time graph, remember anything above is positive, anything below is negative, and this is 0. You're going to start with a negative velocity of -8. Okay, so it's going to look like this. So -8, -6, -4, -2. So I would start with a velocity like right here. And if I'm slowing down, I want to go towards that x-axis. I want to go towards 0. Okay, so the closer you get to that x-axis line, that means you're slowing down. You're going towards 0, and if you touch it, that means you're going to stop. Okay, so that would be the graph for that, because now you are approaching 0. Okay, so you got to really get it stuck in your head that this is a velocity versus time graph. And if you're going towards 0, that means you're slowing down. Now, if I were to look at this one, now I got a mixture of both. Okay, so this one is going to be slow. We just did this one. So slowing down in the negative direction. It stops down here because it had to turn around somehow. And now it is speeding up in the positive direction. Okay, so I'm going to go back over here. So I have a positive on top, negative on bottom, and 0 in the middle. I'm going to start with a negative velocity and go towards 0 since I want to stop. So I'm going to start down here. I'm going to go towards 0. Now, once you hit that x-axis line, that means you're going to stop. Okay, which we did. Okay, so like basically these points right here are the exact same. Okay, now once I stopped, I turned around. Okay, I'm going the positive direction now, and I'm speeding up. Okay, so if you're speeding up, that means you're going to be going away from 0, and you're still going the positive direction. So that way, that's what it's going to look like right there. You just keep going through the line. Okay, so I'm going to kind of explain this graph a little bit more. Is you have a negative velocity, so negative velocity, and you are approaching 0. Okay, so that means you're slowing down. Then right here, once you hit that x-axis line, that means you stopped. And then now you have also turned around or changed direction. And then on this line right here, okay, we are now going away from 0. So that means your velocity is going to be increasing in the positive direction. Okay. So let's go on to the next one. Let's try some more practice. So if I look at this graph right here, it looks like I basically start with a slope of nothing, and then I start speeding up as I go down. Okay, so this would be speeding up in the negative direction. Okay, so let's look at our velocity versus time graph. So I have positive on top, negative on bottom, 0 in the middle. If you're speeding up, so basically it looks like I had a velocity of 0 right here because it's basically flat. And then we'll go ahead and say this is going to be -1, and then -2, and then -3. So again, those are just velocities that I'm making up. Okay, the point is your velocity is getting higher in the negative direction. So I'm going to start at 0 because that's what we did here. We basically had no slope at all. And we're just going to keep speeding up in the negative direction. Okay, so it would just be like that. Okay, you're just going away from 0, just in the negative direction. Okay, so let's look at the next one. Is I'm going a positive direction. Okay, and it looks like I'm slowing down. Okay, my slope is starting to get flatter and flatter, so we are slowing down in the positive direction. Okay, so remember, anything above the x-axis is going in the positive direction. Okay, so just because you see a negative slope doesn't mean it's going the opposite way. It just means it's slowing down. So it's going to be going towards that 0 line right there. Okay, so again, I'll kind of rephrase that. Is anything above the x-axis means you are going a positive direction. So above x-axis equals positive direction. Okay, so this graph right here is, you notice it's slowing down, but we're still going the positive direction. So when I bring that over to this graph right here, is this whole area is positive direction. I'm just slowing down. I'm just going towards 0. I haven't turned around or anything. I'm just going towards 0. Okay, so that's basically how we correlate those two graphs with each other. Now, if we go down to the next one, it's just a mixture of both. So we have slowing down, which we just did. So slowing down in the positive direction. And then we stop. And then we start speeding up in the negative direction. Okay, so now we got to take this over. So I have positive up here, negative down here, 0 here. Okay, so if I look at my graph on the left, so I'll use a different color, is I am slowing down in the positive direction. Okay, so remember, anything above the x-axis is going to be in the positive direction. So if I'm slowing down, I'm going to go towards 0. So it's going to be looking like that. Now, once you touch that x-axis line, that means you stop. So like right here would be the same thing as right here. Okay, that means you've stopped. Now, if you've turned around and you start speeding up the other way, that means you're basically just going to keep going through that line, and now you're speeding up in the negative direction. Okay, so again, that would be slowing down in the positive. This is going to be where you stop and turn around. And then this right here is going to be speeding up in the negative direction. Okay, this one right here, this is just kind of a summary. So we're just looking at basically the track people. So you got a track runner basically facing this direction. We'll say that's positive. Okay, it doesn't really matter in this case since they're not moving. But if you look at the D versus T graph, this just means they're staying at the same position the entire time. They haven't moved. So our velocity versus time graph is nothing. Okay, you have no slope. It's just staying along the x-axis. Then I have one going the opposite way. So now my position is in the negative. But still, we're not moving, so therefore your velocity is nothing. your velocity versus time graph, there's nothing there. Now, constant velocity, that means you are constantly increasing at the same amount. Okay, so that means I would keep a constant velocity there the entire time. Okay, no matter what direction. So in this case, it was constant negative on this one. So you're going to stay at that negative velocity the entire time. So that would be stop motion and constant. Now speeding up in the positive, so this would be speeding up in the positive. So therefore your velocity is going to increase in the positive as well. Now here you're speeding up in the negative direction. Okay, so therefore on your v versus t graph, you're going to be going away from 0 in the negative direction as well. Then slowing down, okay, so your curve starts to flatten out, so you're slowing down, you're still going in the positive direction. So what's going to happen on that v versus t graph is you're going to start going towards 0 above the x-axis. Okay, so this is still positive, this is positive, and then this would be slowing down in the negative direction. Okay, so that means I'm going towards 0 just on the negative side. Okay, and that'll end this video.